Greetings and welcome to the introduction to astronomy. In this video, we are going to be talking about the seasons and what the reasons are that causes the seasons to occur on Earth. So let's go ahead and get started. And first of all, what is the underlying cause of the seasons? Well, it is the tilt of Earth's axis by 23.5 degrees. Now, the fact that it is exactly 23.5 degrees is not what causes the seasons. It is the fact that there is a tilt. Now, often people will think that the changing distance between Earth and Sun causes seasons. Well, we've already looked at there are times when Earth is closer to the Sun and further away from the Sun. And you might expect that things would be warmer when we're closer to the Sun and closer when we're further away. However, let's go ahead and think about this and use our scientific method. If this is the case, because the Earth does have an elliptical orbit and does vary by about 3% in distance, it makes a prediction that the seasons would be the same in the northern and the southern hemisphere. However, we know that when it is winter in the northern hemisphere, it is summer in the southern hemisphere. So the seasons are opposite. So because our prediction does not come true, that requires a modification of our hypothesis. And we look back to see, what is the cause and what else could cause the seasons. Now, another thing with looking at the changing distance is that it turns out that the Earth is closest to Sun in January and furthest away in July. So for those in the northern hemisphere, that is exactly the opposite of what you would expect for seasonal changes. So what is changing? We talked about the 23.5 degree tilt. So the 23.5 degrees that the Earth is tilted, that means that it's going to cause two things to change. One is how directly the sunlight strikes Earth. And two is the length of daylight, how long the days are. So let's go ahead and look at this. Here we see how directly the sun is hitting us. So for a location, say around the middle of the United States, you might get something like 73 degrees for the altitude of the sun in the first day of summer. So that means you are concentrating those rays, and those rays coming in, that 1 square meter of rays spreads out over 1.04 square meters of space on the ground, concentrating that energy in a much smaller area. In winter at the same location, the altitude of the sun may be more like 26 degrees. Well, when you calculate that out, 1 square meter worth of light, the same energy coming in, is now spread over 2.24 square meters of ground. So it is much less effective at warming things up. So that is one of the reasons. The other is the length of daylight changes, that the sun will spend more time in the sky during the summer. So when we look at the path here, this is the path of the sun on June 21st. So for the northern hemisphere, the sun rises north of the east, goes up high in the sky, and then comes down and sets north of west. So it spends a very long time in the sky, giving us more than 12 hours of sunlight. On December 21st, let's look where the sun is. It's well below the celestial equator now. And we can see that it rises south of east, gets up low in the sky, and then comes down and sets south of west. Now that will mean it will be in the sky much less than 12 hours. And you may be familiar with this. Depending on where you live, the further north you go, the more extreme this becomes. So the days get longer and longer in summer, and the nights get shorter, and the days become shorter and shorter during the winter months. And that is the second reason that we will get, there's less time that the Earth is exposed to the sun to warm it up in the winter. Now, let's look a little bit about how this happens around the world. Let's look at some of the different terminology we have here. And we have, first of all, the Arctic circles. These are the Arctic regions very close to the Earth's axis. So very far northerly or very far southerly latitudes. When you get to the Arctic and Antarctic circles, these are the points where at least one day of the year the sun will be up for 24 hours. It will never set. So if you go that far north, now that goes into the northern part of Canada, northern Alaska, northern parts of Scandinavia, much of Greenland here. Those are regions where you would see the sun up for at least 24 hours. And the sun would get a little higher in the sky, would come down, maybe skim the horizon, but never actually drop below it. We also have the tropical regions, the Tropic of Cancer in the northern hemisphere, the Tropic of Capricorn in the southern hemisphere. And if you're within that range, then you are always going to have the sun at the zenith at least one day a year. For the tropics, exactly one day a year. And in between there, you would have the sun overhead 2 days a year. But it's always close to the zenith. So it will always be close to straight overhead, no matter what time of year it is. So those are the tropical regions that are very hot. The Arctic regions, while the sun may be up for a long time, it's also very low in the sky. So that energy is all spread out. So you do not get a very you do not get very warm areas in those. Now, if you were exactly at the equator, then day and night would always be 12 hours long. So the closer you get to the equator, the less variations there are in daylight. The further you get from the equator, the more variations there are. Now, if you actually go to the North or South Pole, then the sun is above the horizon for 6 months and below the horizon for 6 months. So for the North Pole, the sun would rise on March 21st and would set 6 months later. And it would be constantly up. You would have sunlight for that entire time. Antarctic, the same thing, except when the sun sets in the at the Arctic pole and at the at the North Pole, the South Pole would then the sun would rise and would remain above the horizon for 6 months. Now we can look at the same thing 6 months later. Nothing changes with what I've told you. But now we see that the Earth is tilted the other direction. So now the northern hemisphere would be receiving less direct sunlight and would have shorter days. And the southern hemisphere would be receiving more direct sunlight and would have longer days. So that gives us our opposite seasons, which we know to be the case, and therefore helps with our prediction as to why the tilt of the Earth causes the seasons. Now, the last thing we want to look at here is to look at the equinoxes and solstices. Well, first of all, at the solstice on June 21st, the sun would then be highest in the sky. Why is this not the hottest day of the year? The sun would be highest in the sky and it's up above the horizon for the longest time. You would think that it would be the hottest day of the year. However, it's usually hotter for the northern hemisphere in July and August after this time. Well, the Earth has just come out of a cold winter and it takes time to warm the Earth. So the Earth does not warm instantly. It takes time to warm up the land and the oceans from the cold winter. And the same thing would happen on December 21st, while this would be the sun lowest in the sky and the shortest amount of daylight. It still takes time to cool the Earth off after a warm summer. Now we can also look, why are the equinoxes not exactly 12 hours? If you look at the sunrise and sunset on the equinox, it should be 12 hours theoretically. However, what we find is because of refraction, this is not the case. And here we see this in our image, our viewer here standing on Earth, looking off and watching the sunset. In reality, the sun is a little bit below the horizon, but the bending of light through the atmosphere makes it appear that the sun is above the horizon. So the times will always be a little bit off because of refraction. Had the Earth no atmosphere, then this would not be the case. And the days would be exactly 12 hours long on the equinoxes. So let's go ahead and finish up with our summary. And what we've looked at here is the underlying cause of the seasons being the 23.5-degree tilt of Earth's axis. It has nothing to do with the changing distance between Earth and sun. This causes changes in how directly the sunlight hits different parts of the Earth and how long the sun is in the sky. The tropics and the Arctic regions have very different seasons. We see very much extremes in length of daylight in the Arctic regions, but very low altitude of the sun at all times, and very little variation in the length of daylight in the tropical regions. But the sun is always very high in the sky. So we see very different seasons. So the seasons vary most in the middle latitudes. When you're very far north or very far south, you see very little in terms of seasonal changes. So that concludes this lecture on the seasons. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.